Hi, and welcome to this episode, an ecology event around the impacts of light at night, featuring Dr. Emily-Fobert, who is a research fellow in the Fishery Science and Biosciences Department of the University of Melbourne. I've had the pleasure of meeting Emily, who did a fantastic talk live for me a couple of years ago and was one of our favourite speakers at the event. She has an interesting perception of life through the marine and freshwater environment and put this to good use with a research piece of work that she did on our little friend Nemo. Now, you know you've hit on luck when you're getting tweeted and repeated and on every form of media when your research has developed so much that everybody's talking about it. And that's exactly what happened with the work that she did on the impacts of light at night on the clownfish. So without further ado, join me and Emily as we discuss this and get an insight into her research. As always, at the end, if you have any questions, please email us at marnie@darkskytraveller.com.au, or you can see her webpage at the University of Melbourne, Dr. Emily-Fobert.
Hi, with a flick of a switch, we turn night to day and day to night. We can change seasons, actions and states of mind. Light is everywhere, used endlessly and very much a part of our modern world. But what is it? How do we use it? And how is it changing our environment and our behaviours? A star-filled sky used to be our evening's entertainment. Now it's Netflix, iPads, or even a podcast. When was the last time you looked at the night sky? I'm Marnie Ogg, and this is Dark Sky Conversations, the podcast that brings people and science together to shed light.
So today we have a wonderful guest. In fact, I've had the joy of hearing Emily-Fobert. Is that how you pronounce it, Emily?
Either that or Fobert. I think originally it was French, but yeah, not really French anymore. So
I think that's my French, my Francophile traits coming through there. So yes. So Emily-Fobert, I can't even say it any other way. Beg your pardon. Is joining me today and you to answer some questions about light pollution, and in particular, a little fish that some of us may know as Nemo and the impacts of light pollution on it. But I'm going to start off, and I never really do backgrounds on people because I think people can do their own background better than I could ever do it. Tell me, Emily, how did you go from being a Bachelor of Journalism major into biology? And tell me your journey.
Research.
Yeah.
Well, I've always been interested in science, and I went into journalism because I wanted to be a science writer. I thought it would be a good career. I'd learn new things every day. Everyone you talk to, you learn new things. It's great. And a couple things changed my career path. The first was I had a few jobs where I was interviewing scientists, and they were telling me all about their amazing research and amazing places. And I just got a little bit envious of their jobs. And I was sitting in an office on the phone doing interviews. Another one was I was an undergrad. I was taking all the science courses that I could as electives. And a friend of mine convinced me to do a tropical ecology field course in Cuba as a credit. And she was a scuba diver, so she also convinced me to get my open water diving license so I could be her research partner on this trip. So we went and spent 3 weeks in Cuba, living on an old fishing boat, doing diving and looking at corals, and it just changed my life. It was amazing. And I remember sitting there on the boat thinking, wouldn't it be great if I could do this for a career instead of sitting in an office? And so
you did.
Yeah. I went back, I finished my journalism degree, but I also did a biology degree as well. And because I was taking a lot of science electives already, it was just an extra year to get the second degree. And I just kind of continued from there. And my career path's been a little bit all over the place, doing freshwater research before actually making it to marine. And then I moved to Melbourne for my PhD, where I did marine ecology for the first time. And that was temperate reefs. So I'm still not quite coral reefs, but I've since really focused on coral reefs after my PhD. So it's yeah, I finally got there.
Wow, it's always a journey. It's very rare you hear somebody say, "Oh yes, I left high school, I left university, and I went straight into this, and I've been doing it for the last 20 years or however long it is." It's always something, and I think it's those layers that actually build upon layers that make you an interesting person and give you that skill set to make research possible in the areas that you're doing, or not just research, but any goals you want to achieve. So you mentioned you moved from Melbourne. Just quickly, where did you come from?
Oh, sorry, I'm from Canada. So I grew up in just outside of Ottawa, the capital of Canada, very landlocked. So grew up by the water, by the Ottawa River, but had no experience with the ocean before this Cuba trip, which was probably another reason why it was so life-changing for me.
Yeah, really exotic for you in a sense. And it sounds in a way that you've made up for it in the meantime, because I also read that you spent some time in the Maldives. Is that?
Yeah. I've had, before COVID, I was very lucky. I got lots of experience for research. I went to the Maldives for a research trip. I went to Malaysia and spent some time in French Polynesia. So I've had, very, very lucky, I think, with my research trips.
But clever. You've chosen well.
And
yeah, fantastic. So I guess let's get on to the topic, because, when I saw the research come out on this, it hit me first on Twitter, and then I started seeing where all the multitude of magazines that picked it up, both professional scientific research papers and just common everyday, Sydney Morning Herald type things. And it basically said artificial light is killing Nemo. So how did you fall into, why did you decide to start studying the clownfish? And
well, I chose clownfish. Well, yeah, I got into looking at impacts of artificial light at night on fish. Not that long ago, like 2017, I joined a colleague, Jack O'Connor, on a research trip to Moorea, French Polynesia. And he was working on a project, or we were working, but it was his funding, on a project on impacts of light pollution on behavior and physiology of coral reef fish at the settlement stage. So when larval fish they go out into the ocean, they have a dispersal phase of a couple days to a couple weeks, and then at a certain point they come back to the reef and they settle into either nursery habitat or onto the reef where they stay for the rest of their lives. So we were looking at that stage, and I think that really turned me on to light pollution, and it's probably the first time that I really thought about light as pollution. I think there's a lot of people, you don't really think of it. And then once I realized that it had these impacts, it's just, you realize it's everywhere, and we don't actually know that much of what the impacts are, especially in the marine environment. So that project was a really good project. We found some really, really interesting results from that one as well. But we kind of came out of that with more questions than we had answers. And so that really started my focus on impacts of light pollution in the marine environment. And so I wanted to look at impacts on reproduction, because reproduction is really, really critical, obviously, stage for, the continuation of populations. It's critical for fitness of populations. And I chose clownfish because they're site-attached species, which means they when they come out of the dispersal phase as larval fish and they find an anemone, and they stay generally in that anemone for the rest of their lives. So unless the anemone is bleached or it dies, but that's a whole other area of research.
Another climate change issue. Yep.
Yeah. I just had a paper come out actually that showed that it's an observation we saw in Malaysia with clownfish actually moving like 150 meters from their anemone because anemones were bleaching, so they're searching for new homes. But generally, they stay in that one anemone for the rest of their lives. So if that anemone happens to be exposed to light pollution, those fish are really vulnerable. Clownfish also live quite shallow, anywhere from about a meter down to, I think, 50 meters is the deepest they've been recorded, but generally like 1 to 15 meters. So they could be vulnerable to coastal light pollution from sky glow, because it's quite shallow, but also from direct sources from marine infrastructure. And clownfish also have benthic eggs, which means
have what? Sorry,
benthic eggs. That's what we call them. So the eggs are attached to the bottom of the ocean. So they're attached to a rock with a reef next to or under their anemone. So that means the eggs don't move. Other fish sometimes have what we call pelagic eggs. So they just release the eggs into the water column and they just disperse off the reef. But because the clownfish eggs are also side attached, that means the embryos in that stage are also vulnerable to light pollution. So I think just that limited movement in multiple life stages makes clownfish a really good species to kind of investigate the potential impacts of light pollution on reef fish. And there's lots of other reef fish who have similar lifestyles. So a lot of fish, when they settle, they recruit to either nursery habitats, so really shallow rock pools or mangroves, or really shallow reef, and then they'll move a little bit deeper as they get older. But some also just settle directly to like a single coral head, 20 centimeters by 20 centimeters, and that's where they live for the rest of their life. So it's not an uncommon lifestyle choice for reef fish, but clownfish just kind of exemplify that.
Yeah. And not to mention it's a fabulous mascot. It's just something that almost everybody can relate to. And,
well, I have to say, I have learned that when you study charismatic species for your study species, it gets a lot more attention.
Yeah, it's sad but true. And it's always difficult when you're the person studying cicada larvae or something that it's not it's not as beautiful. As you were talking then, I was thinking about, actually, particularly you mentioned Moorea, and I was thinking about the overwater bungalows that would probably be exactly these places that the clownfish is nesting, and wondering, how prolific is this issue? Do clownfish, I guess there's coral caves and atolls, etc., that are further away and perhaps less impacted by sky glow and immediate light sources. But yeah.
Yeah, so that was one of the reasons I think I really focused on light pollution after my experience in Moorea. Like, it is a pretty remote tropical island. There's not that much development on the island, and still the light pollution is really prevalent, especially from these tourist destinations like overwater bungalows. And so it just makes you realize light is everywhere. It's hard to say. I mean, the research hasn't really been done beyond my study of what the actual impact of this is on clownfish. Like I mentioned, most coral reef fish have this larval dispersal phase. So once the clownfish hatch from their eggs, they will go off the reef and disperse for about 2 weeks before coming back and settling to the reef again. And some fish come back to the same reef, and some fish go like long distances. So you really need to understand how those populations are connected to really get to what actual impact is of the light pollution. So what could be happening is there's certain populations that end up, not producing any viable offspring, but fish from other reefs might still come back and settle there. So it will have an impact, but it really depends on how the populations are connected and whether, a population will go extinct or not if it's got, fish elsewhere to kind of rescue it.
I guess that's the same as territorial animals, really, isn't it? It's, you could have a group of marsupials or whatever in a tree that are completely impacted by, but maybe they move on. But as seems to be evidence with birds, is that you then have the tiny weeny space of area that is actually right for them, absolutely overpopulated with species as well.
Yeah.
Yeah. So I'm just looking a little bit into the research you did. It mentioned that you had 10 sets of clownfish. Is that correct? And then and they were pairs. And it mentioned that when you put them under artificial light and they were going through this process of, the eggs, everything, only 86% of them actually hatched. Is that right?
Under the light?
Yeah.
No, under the light. So,
sorry, 86% didn't, I think. Yeah.
Yeah. So, So I had 10 pairs of clownfish in my lab, and I monitored how frequently they were spawning, whether the eggs were being fertilized, how many eggs survived to hatch, and then how many larvae actually hatched. And I found there was no impact of the light. So I had two groups. I had a control group and a light group. So I compared the spawning frequency and fertilization rates between the control group and the group of fish that were exposed to light at night. And so there's no difference in the spawning frequency or how many eggs were fertilized. But when I looked at hatch rate in the control group, we had pretty consistently around 86% of the eggs would hatch. And for the eggs that were exposed to light at night, we had 0% hatch. And it was a very small sample size. I was limited by how many fish I had and how many were actually decided to reproduce. I wanted them to. I also learned reproduction studies are really challenging. Don't always cooperate. So it was a small sample size, but the really convincing thing for me and I think for everyone why it was published and why everyone picked it up was I then removed the lights and monitored the reproduction again for a period of time. And as soon as I removed the lights, the eggs from the parents that were exposed to lights hatched again at like 86% hatch rate. So back to exactly the same as the control group. So it's clearly that presence of light that was doing something that was inhibiting the eggs from hatching.
That's amazing. And can I just clarify, were they the same eggs? So were they the Allen eggs that were sitting there and then as soon as you turned the lights off, they started to hatch? Or was it at another round that you did that? Yeah. Okay.
Yeah. So yeah, it's a different clutch, different group of eggs, but same fish. So I guess my questions were, is there something happening, to the parents? Is their behavior changing? Because they spend a lot of time caring for the eggs. So I thought perhaps the parents aren't investing as much in the eggs and for caring for the eggs, maybe they're not developing properly and they just don't have the ability to hatch. But it wasn't the parents because the next clutch of eggs hatched just fine.
And so the parents were constantly around in both scenarios. Alan, yeah. Yeah, amazing.
You're listening to Dark Sky Conversations with Marnie Ock. We'll be right back after these messages from our sponsors.
So is there more research going into this? Is there a next phase of this? Is there a solution that you're trying to pose to this, or what's next?
Well, I think the solution is turn off the lights when you can. I have lots more questions. I'm still working on a few. I've done a few more studies from that from my last job. So that was all done when I was working at Flinders University, and I had a lab fish, which was great. So I've got 3 more papers that I'm still working on getting out there. So one of them is looking at that parental care. So, if the light was also affecting the behavior of the adults during that stage, because that could also will impact the parents' fitness and their subsequent reproduction if they're spending a lot of energy caring for the eggs, or if they're spending less energy because they're really stressed, that can affect them long term, their reproductive fitness. And I just actually analyzed that data yesterday, and their behavior changes slightly, but I don't think it's
Okay.
significant. And I have another study where I'm looking at physiology. So what, not related to reproduction, but just what happens to fish that are exposed to light? How does it affect their oxygen consumption? So their stress levels and their metabolism, and which has impacts on their.
Of course.
Yeah.
Just a question which I didn't ask is, was there a particular type of light that you were exposed to these fish to? Was this just a typical, normal, whatever the average marine light is, or was it ambient, sky glow type light levels? Or
So I used just LED lights, so it kind of what's the word? As a sort of direct source of light. So. Yeah, I know, like sky glow is still an issue for sure, but I guess I'm thinking more about for clownfish who are directly under or next to the lights coming off of these overwater bungalows or piers where they've got lights shining down into the water. So it's more of a direct source. So that I use light levels of approximately 15 lux for the reproduction experiment, which is higher than sky glow, but some lights coming off piers or bungalows reach up to like 200 lux. So it's conservative in that sense. I had a student do a follow-up study on the reproduction of clownfish and looked at whether different wavelengths of light had different effects on the size rate and the reproduction. And not surprisingly, I think bluer wavelengths had more impacts on the reproduction and the embryo quality. So she actually looked at the size and condition of the embryos before they hatched. But overall, the finding was light is bad. So whether it's the blue light or the warm yellowish wavelengths, they still didn't hatch. So
it still didn't hatch, right?
Oh, we had slight. I think we had like 4 or 5% hatch rate, but it was still massive.
It's minimal. Yeah. So you've got these light traps, basically, where the fish are staying, and it reminded me a little bit of the work that Andre Chiaradia does at Phillip Island in Victoria as well, where they have the shear waters and for a period where they're, I guess, migrating or learning to fly. I'm not sure when it is exactly, and in fact I should have him on as a podcaster. But they turn off the bridge lights and the environment lights for a certain period of time, knowing that is going to be the most influential and successful for the birds. Is there something that you could recommend for clownfish? Is there a breathing season that we could turn the lights off for, or out? Is it 3 hours a night that they must be turned off that would help? I don't know.
Yeah, so that's a good question, and yeah, I think that's a good future study to confirm. I suspect that there's not really a breeding season for most clownfish, depending on where they are, and latitudinally. So in those tropical areas where there's not really those seasonal changes and it's quite warm all year round, the fish often spawn year round. And clownfish will spawn 1 to 2 times a month, I think. Again, depending on temperature and light and everything. And they're not always like synced. So that would really require turning lights off all the time, because there's not really a single season, a single week of the year, month of the year that it's really important.
It's not like turtle breed, and again in Queensland, I think they have the week in Bundaberg where they turn all the street lights off and house lights off just to help the hatchlings make their way to the beach. Yeah.
But I think that most clownfish and a lot of other coral reef fish, the larvae will hatch just after sunset. So this helps their survival if they're hatching when it's dark and there's not as many predators that can see them. They're quite small and transparent at that stage. So I think if it's dark, they just kind of escape off the reef without being noticed. Compared to if it's, bright out, there's probably lots of predators there waiting for them. So depending on the species of fish, I don't know exactly what that time frame is, whether it's an hour after sunset or 3 hours after sunset, but it is possible that, delaying the onset of lights for a couple hours could help some fish hatch better. But that's probably also when people are still awake and up and going out for dinner on the overwater restaurant and want the lights on. So it would be nice if it was in the middle of the night.
Yeah, it would be. It kind of makes me think, though, we seem to have forgotten the art of personal responsibility. So could you not, just give everybody a torch to get back to their cabin? Do you have to have lights pelting down for 7 hours every night or more, depending? And yes. It's still safe. It's still, anyway, that's just a little tirade on my Yeah. I had another question. I've gone completely off course. Anyway, I think that the question is always around when we're using lights, how do we use them? And it always comes back to, it's an environment that didn't ever have it before 150 years ago, and we haven't evolved, including all the species. Yeah.
I think the answer is always, if you can reduce the light, whether for a duration of time or an intensity, it's going to be better for wildlife, just in general.
Well, the first principle of the National Light Pollution Guidelines is recognise that darkness is an asset. Yeah. Consider if you really need to light it. But we've fallen into the trap of making light the standby option, haven't we? It's meant to keep us safe. It's meant to, it's just there. We just incorporate it into all of our buildings and all of our infrastructure, and Part of ADS's role, I guess, is challenging that a little bit. And actually, that's what I was going to say, is that it's really interesting that as humans, we tend to think of darkness as being scary and something that we try to avoid. And yet you look at the natural world, and so many species actually need that cover of darkness to commence their life, or to keep safe, or to hunt, or to...
Yes, exactly. But as humans, we are diurnal. We're not nocturnal. So, our world is very human-centric at the moment. And we don't have the eyes to be able to see as well at night as a lot of animals do. And so, for us, I guess it is a bit scary if we were living in the caves every day, and that's when the lions would be out hunting and we would be hiding. So,
although I think there's a lot of research to say too that we've become dependent on light, so our eyes aren't adjusting as well to darkness. We're not, when we also don't give ourselves time to adjust to darkness. We walk out of our bright houses into darkness, and we, of course, we can't see. But if we've been out there since, and I often do this with groups, to start groups at twilight, and it becomes dark, and you haven't even realised, because you've been adapting the way the evening has naturally been adapting as well.
And we're not afraid of lions anymore, so we can deal with this. I think.
I think you wouldn't think so. So, Emily, I know you're also heavily involved with a group called Nero. Mm-hmm. Do you want to tell us a little bit about what they're doing and what your aims are with the group?
Sure. So Nero kind of came out of a desire I had for connecting with other researchers who were interested in impacts, ecological impacts of artificial light at night. So when I was at Flinders working on the clownfish, there wasn't really anyone else at the university who was interested in the same questions that I was. And that's a really exciting and great place to be as a researcher, but it can also be, a little bit isolating. You don't have people to bounce ideas off of and develop questions. And you
can find yourself inventing the wheel again and again. Someone's already done it, and
exactly. And I'm a big believer that collaboration leads to much better, more comprehensive science. So I didn't like that I was just kind of doing my own thing all by myself. And so I saw on Twitter, actually, that there were some researchers in Sydney who were starting a project on coastal light pollution in Sydney Harbour. So that was Katie Deforn at Macquarie Uni and Mariana Meyer-Pinto at UNSW. So I actually just sent them a message on Twitter, pretty much said, "Hi, I see you doing research on light pollution. So am I. It'd be really great if I came to Sydney and met up with you guys and found out a little bit more about your research, and maybe we could come up with some ideas to collaborate on a project." And so we discussed having a little workshop in Sydney with the group of people in Sydney who were working on this coastal light pollution and myself. I thought it might be 4 or 5 people. So I applied for some funding to hold a workshop. I was successful. So I started emailing people that I knew might be interested in light pollution, thinking, maybe we could grow it to about 10 people. And it just went crazy. Like people started emailing me, like, "I hear you're organizing a workshop. I'd love to join." I had to turn people down at the end because I capped at about 25 participants.
This is all before COVID too, wasn't it?
Yes.
Just, I think. Yeah.
Yeah. This was 2019. I was organizing it. So yeah, I had massive response. And at first I thought I would just, get to know some of the other people in the marine field. And then it grew much bigger than that to like terrestrial ecologists, physiologists. We got managers, like local government, federal government representatives, and practitioners all wanted to join. So we had, about 25 participants in the end, which was fantastic. And we held a workshop in Sydney, February 2020, just before COVID entered Australia. Really, really good timing for that, to have an in-person workshop. What in my mind was hopefully just a small workshop where I could meet some other researchers with similar interests and hopefully come out with some collaborations. Ended up being a 3-day workshop with, researchers across fields, managers and practitioners, where we discussed impacts of light pollution on ecological impacts of light pollution. Everyone presented some of their research. We discussed ways going forward, and what managers want from us, from researchers to help them do what they need to do. And it was really clear to me during the workshop that this was something that a lot of people wanted, to be connected in this space, and people wanted to continue that connection, that collaboration going forward. So we discussed officially creating a network in the workshop, and then Nero was born, the Network for Ecological Research on Artificial Light. And it's become much bigger and better than I ever imagined. And
It's fabulous. So well done you. So putting your hand up and just asking for a bit of collaboration. And it's amazing. It really is. And I think what it shows is that there's been, in my mind, an absence of conversations about light pollution in Australia for a very long time, or that people have been doing it, but they've been doing it singularly. Mm-hmm. And it really requires us to actually come together to talk about it with a larger voice, in our own little areas, in our own areas of wisdom and connection, to grow it. Because I know that sometimes I've had conversations with people in the Northern Hemisphere who have said, "Oh, there's not much happening in the Southern Hemisphere." Well, there is.
Yeah,
there is.
Surprisingly a lot. Yeah.
Mm-hmm. If I may, I might just delve into a a question that I know, well, I don't believe you have the answer for, but in that workshop, because I think I attended the first day, one of the questions was raised was, well, how can we come up with a way that we can collectively measure light over land and sea, that we can all start talking the same way, so that we're actually comparing apples with apples and oranges with oranges. And maybe you can just talk about some of the complexities of that. So,
yeah, it is complex, and I don't believe we have an answer yet. There has been some research come out in that space, some papers recently that discuss that in depth, which is good. I think that there's a lot of, not just Nero, but other groups in Europe who are also trying to answer this question. It's difficult because the impacts of light are very species specific in a lot of ways. So different species will respond to different wavelengths and different, like they will perceive light differently. So in terms of understanding ecological impacts, you have to kind of understand how the species you're interested in is perceiving that light. And, sky glow interfering with turtle migrations or turtle navigation towards the ocean as they emerge from their nests, that's very different light than like a direct light source. A great light or a light from a pier that's shining directly onto an anemone. So measuring that light, it's difficult to have a standardized measurement that captures all the aspects of light that affects all the organisms that you'd be interested in. And on top of that, there's the complexities of measuring light underwater versus on land. So light penetrates water differently than air. Blue wavelengths penetrate further than the warmer red wavelengths. And that also depends on what kind of water you're looking at, the turbidity of the sediments in the water. And then a lot of instruments that measure light don't go underwater. So it's just really, it is challenging to find one measurement that you can measure, in all realms and for all organisms, and just use that to understand what's happening at the organism.
And then I guess there's the question, the point that you made earlier too, is that light might be more impactful at certain times of the evening or the day to a specific species than another. And and I guess that's probably more easy to qualify, because you can, as a researcher, know that and then you can work that out. But it does make a difference as to the the way the machine is measuring it, I guess. When do you what conditions is it built for? I think in a lot of fields, I think there's a desire to standardize things that you can compare across research, across different groups doing different things and different questions. But I don't think by standardizing, you're going to actually capture everything that you need to understand for different questions. Sense. I don't know. It's a tricky one. And some people probably disagree with me, but. Well, I think it's a little bit like psychology, which is an area that I spent a lot of time studying in. And, we've got the DSM-4 or whatever it is, which talks about, you've got these attributes and therefore you're schizophrenic in this and this, and we've pigeonholed people. And yet at the end of the day, the most beneficial work that you do with people is when you throw away that book and you just talk to them as a person and you delve into them specifically, because that person's different to everybody else. It's just a matter of time, really, isn't it? And funds or whatever is required to make it work. Actually, as you were talking about the different lights for different species, I was remembering Kelly Pendoley saying that the same turtle, and I think it was a loggerhead, in Florida, for example, reacts differently to light waves there than they do in Queensland. So the same species is not even dealing with light the same way.
Yeah. So it's very difficult to generalize anything, except for, I think, just that light in general. So that's the only generalization that we can make, I think, about how ecosystems and organisms are going to react. Just that light is disruptive.
Yeah.
So I think finding a wavelength to use instead of, what we're using now that is less impactful. Those are good strategies to consider. But again, because every species is going to be differently sensitive to different wavelengths, it might be less impactful for some and then more for others. I think the only thing that we know is that reducing light will be better.
And it's really hard for even the best and most well-intentioned engineers and industrial, designers, lighting engineers who really want to do the right thing. And they say, okay, well, so what are the boundaries? We want to work between this and this. Tell us what it is. Well, as you've just said, that shifts so many, it's shifts so many times. It's fluffy as people talk about ecology. It's fluffy. You can't.
Yeah.
Yeah. Well, look, we're almost at the very end of our conversation. It's gone so quickly and I really enjoyed it. But I can't go without asking you what your most memorable dark sky experience is. And I think most people that have turned their attention to light pollution also remember the minute that they discovered darkness. Mm-hmm. What was yours?
Well, I grew up, like I said, just outside of Ottawa in Canada, and I lived in the country. So I think I always had relatively dark skies compared to a lot of people growing up in cities. So that didn't turn me on to light pollution at that age. But I do remember I lived in this house that had a kind of a deck in our roof. It's really weird, but I remember going up on the deck and with our sleeping bags and watching meteor showers with my sisters and my parents. And I think one year my sister got a telescope for her birthday, and so we went up on the roof and look at stars. And so those are my earliest memories of darkish skies. I'm sure there was still some light pollution there, but it was pretty remote where we lived. I was always fascinated by the stars.
I think everybody is. I've never really found anyone that says, "Oh, yeah, well, seen one star, seen them all." But what is it is the fear is when if you never see it, you don't appreciate it. And that's what happens. And I love the fact that often when I ask people that question, it's memory related to family or, something quite potent about growing up. Yeah. Very nice. So if people want to know more about you, Emily, where can they find you?
They can Google me.
I guess it's Nero. They can look you up at Nero.
NeroOz.com. Find more information about the network. You can send me an email anytime, emily.fobert, Fobert at unimelb.edu.au.
Emily-fobert.
Yeah.
Fantastic. Well, that would be great because I'm sure people will have lots of questions and you might get inundated. But if they, if you also want to ask any questions to me and I can forward them to Emily as well, that's also fine. So anyway, I'd love to thank you for your time, Emily. I know how busy you are and how you've been able to fit us in for this today, but it's been wonderful. It's really nice to see you again too, looking so well.
Thanks for having me. Love talking about clownfish.
Have you on again. All right. Good luck. Thanks for the research.
Ready.